Hello everyone. This video is going to go into detail about how to use counter instructions. So with this right here, we're going to be using some of the same uh, input instructions and output instructions, and we can even use timer instructions to make these things happen. So I'm going to give you a demonstration of a little bit of all those. The first one is just going to be a simple of how to make a counter count. Okay, so the first thing I want to do is we're going to get an XIC, or first we're going to put in a rung, then we're going to go up here and get an XIC, then we're going to go to the timer counter tab, and we're going to get a CTU, because a CTU counts up, a CTD counts down, then a reset, an RES resets a counter or a timer. Okay, so we're just going to get a CTU. We're going to click and drag. Now we're going to give our XIC a tag name. So I'm just going to right click on the question mark, select new tag, and I'm just going to call it input 1. Now this doesn't mean it's actually a hardwired input. It's just something that I'm going to call input 1, so that if I have several inputs, I'll start with number 1 and the next one will be number 2 and so on. So I have a tag name, I have a data type of bool, and an XIC is an instruction that only can use a bool data type, and it is controller scoped. So I'm going to hit create. Then we're going to have to name the counter. Just like a timer, the counter has to have a name. So just like any other tag, we have to, or any other instruction, we have to create a tag for this counter. So we're going to go to the question mark, right click, select new tag, and just like the timer, I like putting the word counter in front of whatever it is that I'm going to do. So it may be counter number of pieces, counter whatever. I mean, it all depends on what it's doing. But I always put the word counter in it, and that way when it goes in my controller database, tag database, they're all in alphabetical order. I can look at all my counters all at the same time, and I can pick out which one I want a little easier for me. So I'm just going to call this counter 1. It is of the counter data type, and it is controller scope. So I'm going to hit create, and I'm going to put in a preset of, let's just say, 5. So what that means is that once we count up to 5, then it's going to go done. Because just like the timer, it is, I want to show you this. If you go into and expand this, you have different suffixes that is combined with the tag itself. So you can get a prefix, which is again a dent. Means that it can be a numerical value with no decimal point. An ACC, which is accumulator, is a dent data type, which is also a whole number that is not got a decimal point. The CU is a count up, so that means every time it counts up, or basically it's enabled like a timer, this will go true, which is 0 or 1. That's a bool. Count down, there would be a 0 or 1. That's a bool. It's done, means that it's reached the set point, which is the preset. That would go to a 1, and all we have available is 0s and 1s, so that's a bool. And over and unders also are bools, so you can only put a 0 or 1 in there. Okay, so just to let you know that these are the suffixes that you can that are associated with a counter tag. So let's go back to the logic. So with this being said, I'm going to download this to the processor just so you can see how, when I toggle the input 1 on, how the CTU will react to that. So I'm going to go to communications, who active, make sure that my controller is selected, it's highlighted, and I'm going to select download. And it's going to ask me if I'm sure if I want to download, and once that pops up, I want to hit download again. back to run mode. You can see that my logic is executing because I have the green power rails. I'm online and we are executing logic. So I'm going to go ahead and toggle this bit on. And as you can see, I toggled it on. It's high. The CU, so it's counting up. So as long as this rung is true, the CU is going to be on. Okay? So I'm going to toggle that off. You see the CU goes off. I toggle again. The CU comes on, and every time we count up, every time this run goes true, we're going to accumulate one more bit or one more number in the accumulator. So I'm going to toggle off, toggle on, toggle off, toggle on. Then now once I get to the 5, I want you to see what happens now. The CU should come on, means that I've counted up one more. And then the done bit should also come on, meaning that it's reached the preset. So toggle, see? So I've reached 5, CU is on, and the done bit is on. Okay, so I'm going to toggle that off. So you can see as long as we have reached the preset, the done bit stays on. I'm going to toggle it one more time. So you can see even after it's past the 5, it's still the done bit is on. Yep. So just so that you know. Now, the way we're going to reset this back to 0 is we're going to add another rung. And we're going to go back to the bit tab, bring in an XIC. So when this closes, we're going to reset. So I'm going to make a new tag. Right click on the question mark, select new tag. Now I'm going to say reset counter TB. It is of a bool data type because an XIC can only have a 0 or 1 value. Controller scoped. Select create. Then I'm going to go back to the timer counter tab and I'm going to bring in a reset. This reset has to be the same tag as your counter or whatever it is that you're trying to, whether it's a timer or a counter, you have to bring in the same tag. Okay, so I'm going to go ahead and accept this. Now if I toggle this bit, I should reset the accumulator value to a 0. Now I just want you to see what happens if I toggle that on. So I toggle that on while it's reset. So this is why you have to make sure your logic is written in a way to where you can't have this reset going on at the same time as you could have an input for counting, or you would have an inaccurate count. So just let you know, there may be a time where you want to hold the count to 0 until this is unmade before you start counting. But either way, just making sure that you understand that your logic has to, you have to be careful about the way that you write your logic so you don't basically inhibit the count because of the way you've got a reset written. Okay, so that's the basic way of getting counts. And that is how you will get a reset for a counter. The next thing I want to show you is how to set up a pulse timer so that you can actually sequence through your logic. And this will go along with other things that we're going to be using later on, but I want to show you this now. So that we can actually, so what we're going to do is we're going to add another rung. We're going to use an XIC. So that's going to basically enable this. We're going to go and we're going to get a timer. And we're going to put in an XIO as well. We're going to make another rung. to then we're going to get another timer. And there's several different ways you can set these up, but this is the way that we're going to set it up for this class. I want to put another rung into here because what I want to do is, let me scroll that up a little bit. I want to show a 3-wire latching control so that, you know, this may be repetitious, but some folks may need to see it again and again. So we're going to create a tag, start PB. It is a bool data type, controller scope. We're going to do a stop PB. It is a bool data type and controller scope. We're going to do a new tag. We're going to do, we've used it before, but we're going to recreate it, sequence latch, and then bool data type because that's an OTE, scope data type or controller scope, create. So we're going to latch that on. Once we latch that on, we're going to say, we're going to make a timer 1 tag, or we'll say timer pulse 1, and it's of a timer data type and controller scope. We're going to set this right here for like half a second, which would be 500. And we're going to go ahead and right click on the question mark, and we're going to create another tag, timer pulse 2. It is of a timer data type and controller scope. We're going to set it for half a second. And you can set these for different times, but this right here, we want it to happen fairly quickly, and we can set these even further down, and we can manipulate that as we write our logic. So basically what I want is that when we hit the start button, I want to latch this on. I want to, as long as this timer 2, so I want to double click on this, I want to go to timer 2, pulse 2, as long as it is not done, I want timer 1 to time. And then I want this one to turn on. When timer 1 is done, I want this one right here to turn on. So basically you're alternating between the two. Like this. So when we latch the sequence, timer 2 cannot have been started because it requires timer 1 to be done before it can start. So that means this will be closed once we hit the start button. This will be closed because nothing here can be on if timer 1 ain't on. And timer 1 ain't on until both of these are made. So once timer 1 times out, it will become done. This will come on, and for as long as this timer is timing, then this right here will go done, which will open this, resetting this back to 0, and the sequence should go back and forth and back and forth. So the reason why I've done this is because what I want to do is that we want to put in another rung, and I want to say that every time that this bit goes true, I want to count up 1. So we're going to go ahead and make another counter. Well, this will be counter 2, counter data type, and controller scope. I want to set it for 5. And then what I want to do there is every time that this timer pulse 2 gets done, and you can come off either one that you want, every time that that one finishes and resets, then I want it to count. Then I want it to shut the sequence off, so the sequence unlatch. I want to put another XIO in here to where once I count up to 5, so I want to go to double click, go to counter 2. When it's done, I want that to open, which then will shut off the sequence. And also when we go to well, we'll go ahead and do this right here again, and because the next thing we're going to be doing is resetting the counter, but I want you to see what it does. So what I'm going to do is I'm going to go ahead and start process. It should sit there and it should start counting, as you can see. Okay, once it got done on the fifth one, there you can see this opened up. We have unlatched. Now, if we would have went ahead and just put a reset in there, it would have just kept resetting. But what we're going to do is we're going to try that. So let's go ahead and put in another run. And let's just put in an XIC so that when counter 2 is done, we want to reset the counter. So we'll put counter 2 there. Okay. So see, as soon as the counter 2 was done already, so as soon as I put the instructions in there, it went ahead and reset it back to 0. So now let's go back to the start. Let's toggle it on. Let's toggle it off. Let's see what happens now when it gets up to 5. See, that's what I figured would happen. And see, it's just keeping on going. So as soon as it gets to 5, it is going ahead and just resetting instead of the counter actually getting done. It's getting done, but this right here is never opening. And that's some of the things I want to make sure that you understand, is that you always have to make sure that your logic is written, because sometimes you'll think that this is exactly how it should work and this, that, and other. So what I would need to do is that when the counter's done, I have to make sure that this sequence latch is actually off, all right, before I reset. That way I can ensure that my latch has been, this right here, that this is off, that this has to be off before I reset. Because if I don't do that, then I could get this just cycling back and forth, back and forth. Okay. So now you can see that, and that's what I figured would happen, and that's why I wanted to show you this, is I want to show it to you again. We're going to toggle to start the sequence. We're going to toggle it back off. It's sitting here pulsing, and it's counting. Then we go to 5, it unlatches, and then after it unlatches, so the counter has to be done, all right, and the sequence latch has to be unlatched. Then we'll reset to 0. So that way it's ready for the next one. You could also do it when you first hit the start button. So if you didn't want to do it at the end of the cycle and reset it back to 0, you could also have just put in this start PB, so that every time that you go to start the sequence again, it always makes sure that your system starts back at 0. And you could even put that in there as an OR instruction, so in case you was ever afraid that it got something happened and you had a count in there for some odd reason, that it always made sure that it started at 0 when you hit the start button. So let's just say that right there. So let's just say if I change this to where I just put in the, let me go into edit mode, and let's just say if I put the start PB in, all right, and I'm just going to take this instruction out, and let's just see how that acts. Okay, so now just when I hit the start PB, will I reset? And one of the things that I would suggest that we do when you do this is so that if you did hit the start button for too long, that you wouldn't miss a count. So the one thing I probably would add to that would be to take a one shot, and that means that that this instruction will only be, so you could hold it for 10 seconds, but it's only on the initial push, the initial rise of the signal, that this reset will take place. So we could leave the start push button on, and it would not keep it reset. It would just the initial push would reset, and then after that, it would ignore everything else. So I haven't shown you this yet. So it's just up here in the bit tab. It's a ONS. So we're going to right click on the question mark. We're going to select new tag, and I'm going to put in one shot. Now what I would do on a one shot is you can leave it as this data type to where one shot has a 0 or a 1 and that's all that's available. But if you do not want to have to make multiple one shots, and in some projects that we do, some labs that we do, we'll be using several one shots. So what I suggest is that you change this to a dent. Okay, just change it to a dent, and that allows us to have 32 one shots from one tag, and I'll show you more about that in just a second. But we're just going to put in the name one shot, and then it's going to be a dent data type, which means we're going to have 32 of those available, and then it's going to be controller scoped. So we're going to hit create. Now we have the one shot, but because it's a dent, the ONS has to be a bit, which means it has to be a bool data type. So now to get it to become a bool, I want to show you this. So here's the one shot, that's the word. You see it's a data type dent. But if I drop down and drill down a little further and go to this 0, that takes it to the bit level, which is going to give us a 0 or a 1 only. Okay, let me show you that a little bit closer here in the controller tags. So let's go to one shot. So I want to see when I collapse this, and here's your one shot. If I hit the plus sign to expand it, you'll see the one shot, this dent is made up of each one of these bits here. All right, 0 through 31 here. Those 32 bits make up this dent, okay? Which is what we normally would use. It's a double integer to get whole numbers without a decimal point, okay? But if we go drill down into the bit level, we could use each one of these as a bool, because see, each bit level of that is a bool data type. So we don't have to make a one shot 1, one shot 2, one shot 3. You can do that. There's nothing wrong with doing that. But this right here I found is just, and it's something that somebody had mentioned to me one time as some advice to me on programming, and I took it and I like it and I use it all the time. So anyways, we're going to go down to the bit level so that this is a bool data type, and you can see it as I've highlighted over it, or I hover over it, you can see it comes up and it says element data type is bool, right? It says the tag data type is dent. So as long as this instruction is down to the bit level, we can use that as a bool. Okay, so I'm going to go ahead and finalize that, accept all the edits, and now what I'm going to do is that let's just say if I started out with a 2 in there for whatever reason, so I just put the 2 in there. When I hit the start button, and I'm going to go ahead and change this up to like 10, that when I hit the start button right here, it's automatically going to hold that or reset it. And see, I've got the start button still on, and it's not resetting it anymore, is it? If I hadn't put that one shot in there, and here's what I'll show you, is I'll take the one shot out. And I'll go ahead and accept and finalize. And you'll see that if I do this right here, when I hit the start button, if I've still got it pushed in, see, it's sitting there staying at 0. Now, with a momentary push button, it shouldn't be of an issue, but let's just say if you have somebody, if people don't, they hold it down for more than a half a second, then it's going to start messing with your actual counts because of how we've got this set up. So just letting you know. So that's the reason why we put the one shot in, so it doesn't matter how long you hold the button. It only matters when it first sees the signal go true and it ignores everything else. So that's why it's important to have one shots in there. Okay, so I'm going to go ahead and put that one shot back in. remembering that the one shot is a bool or is a dent data type, but if I go down to the bit level, I can use that as a bool. Okay, so I'm going to go ahead and put that in, and now we should start counting. Okay, so here's another thing I want to show you that we can actually go. Let's go down to where it's even faster. So let's just go down to here's going to be a tenth of a second. So let's just go up to like 25. This should go pretty quickly. Okay. So now if I hit the start button, toggle it on, back off. See, sometimes you can't even see the numbers really update. It's going so fast. So that's really it for this. This right here shows you a little bit more about timers, introduces you to counters, resets, and also shows you a little about a pulse timer, which we're going to use a lot to sequence through different rungs of logic as we get going. So if you have any questions on this video, just please let me know. Thank you.